Okay, so we saw that we spend quite a bit of our resources on acquiring energy. So we saw that we spend one out of $10 on energy. So why is it that we need energy? It turns out that to do work, you need energy. So energy is defined as the ability to do work. So, by the way, so here's the law of conservation of energy. Now we'll learn various forms of energy out there and some of the physics principles behind this. So energy can neither be produced nor destroyed. And so when one says that energy is produced by a nuclear reactor, for instance, okay, so what one is really saying is all we're doing is one refers to the conversion of one form of energy that's not suitable for our needs. So that is nuclear binding energy into another form, such as electrical energy. So that's what a nuclear power plant is doing. It's converting nuclear energy into electrical energy. We're not creating or destroying energy. So energy cannot be produced or destroyed. We cannot be created. So what a nuclear power plant is doing is it's converting nuclear energy into electrical energy. And as we said, electrical energy is the most useful form of energy for us. Okay, which we can utilize. We can transport more easily and utilize in factories and stuff like that. All right, so let me show you how we use the way we produce electrical energy is based on the principle of Faraday's law. Okay, and so let me show you a simulation that shows you how all electricity is produced right currently. Okay, so let's go here. Okay, so you can find this simulation on my website. Okay, uh, and I will. I've lost my pointer, so but I'll just start this. Okay, so you can see in the simulation, you have a loop of wire between two magnetic poles. Here, the North Pole and the South Pole, and this loop of wire is connected to a bulb. Okay, and you can see that the loop of wire is not connected to any battery or anything. It's just connected to a bulb. Now, if we rotate this loop, okay, so if you rotate this loop, what happens is uh, electricity is produced. Okay. So now the question is, how do you rotate this loop? Okay. Now, if you can have a crankshaft and rotate this loop, okay, so and you can produce electricity. Okay, so this is a generator. Now, in a dam, the flowing water is used to rotate this loop. In a windmill, the wind turns the blades of the windmill, which are turning this loop. Okay, and so that's how you're producing electricity. So what you're doing is in the dam, you're converting the potential energy of water into electrical energy. In a windmill, you're converting the kinetic energy of the motion of the wind into electricity. In a coal power plant, you burn coal, you produce steam, and the steam turns this loop of wire. So in a coal power plant, you would be converting the chemical energy of coal into electricity. In a nuclear power plant, you would split a nucleus, the nuclear binding energy is released. You use that heat to produce steam, which in turn turns this loop of wire, which is producing electricity. So again, this generator, so the generator is not an appropriate name, but anyway, the generator, what it's doing is converting various forms of energy into electrical energy. Okay. Now we'll be referring to this generator uh, often, so keep this simulation in mind. And you can find this simulation on my website. Okay, so let's get back to the PowerPoint. Okay, so the Faraday's law is the basis for all production of electricity currently. Now, solar cells don't are not based on Faraday's law, so in the future we'll be producing electricity in a different manner. But right now, Faraday's law and this generator is how we produce electricity, all our electricity, at least. Okay, so you can go to this link and look at that simulation again. All right, so let's learn some physics terms that we'll be using in this course. Okay. So we saw that to do work you need energy, and work is defined as if you apply force F on an object and the object moves a distance d. So the work you have done is F times d. Okay. So for instance, if you apply 10 newtons of force and an object has moved 2 meters, you have done 20 joules of work. Newton meter is a joule. Okay, so that's what that means. Okay. And force, the force you have applied on an object is equal to the mass of the object times its acceleration. Okay. You can also do work when you lift an object up. So what this is saying is if here's a box and you lift it up through a height h, the work you have done is the mass of the box times acceleration due to gravity times the height through which you lifted. So that's what that formula says. Okay, we need to understand the concept of power. Okay, so when you climb up a stair, so you're lifting yourself up that height, and we just saw that when you lift yourself or any object, you do work. The work you've done is m, your mass times g times height. Okay, so that's the work done. Now, the idea of power is the following. Power is defined as work divided by the time over which the work was done. So the smaller the time you take, the greater the power. So if you walk up the stair, your power is slower, and as if against if you run up the stairs, your power output is higher. Your power will be higher. If the time taken is slower, then the power is higher. Okay. Now you saw that work to do work you need energy. So the energy needed is power times time. Okay, so power is work over time or energy over time. So energy would be power times time. Okay. So for instance, your electricity bill, the electric company charges you for the total energy you use. They don't care at what the power rate. So your electric bill is for the total energy used, which is power times time. Okay. So there are various forms of energy. There's kinetic energy, gravitational potential energy, thermal energy, chemical energy, nuclear energy, electrical energy, which is the most convenient. And so we will see ways, you already saw ways of converting nuclear energy to electrical energy, chemical energy to electrical energy. In a coal power plant, you burn coal. From the heat released, you produce steam, which turns that coil to produce electrical energy. Okay. And electromagnetic energy is energy of radiation like light, X-rays, and all that. So we'll talk about all these forms of energy.